Welcome to the Airgas educational video covering basic installation requirements for a new GMX unit. The following video was taken during a training session and should help to get you started on the required piping to install your GMX. However, this is not all-inclusive. Please refer to your user manual for more detailed instructions, and if you have further questions, refer to the contact information below. Thank you.
Here is a pretty basic installation drawing, but it illustrates what needs to happen, to a customer when this unit shows up on site. So there's some value in going through each of the components on this page. So let me start with the basics. We have nitrogen that comes in, nitrogen, CO2, and carbon monoxide. In most cases, the nitrogen and the CO2 are coming from a bulk tank. Occasionally, we've had it where a customer has used microbulk, and that can be done. The possibility of running out is greater, with a smaller volume type thing. So normally those come from a bulk source. The carbon monoxide source almost always comes from cylinders, and you see that we show regulators here. We really should probably show a regulator on all three lines, but in the case of the carbon monoxide, typically it's coming from a changeover manifold located inside of a gas cabinet or something like that, and it's already regulated down. The important point here, though, is that with all three of the gases, that the incoming pressure should be right around 140 psi, and I think the Airgas has a max of 145 psi, but it's important to keep it at 140 psi and not much greater than that. I think it goes without saying that all three of these gases are pures. There's some mixers out there on the market that actually use a blend, or what they call a master mix on the CO. Ours does not do that. We use pure gases, pure of all three of these gases that comes in. This mixing unit up here is responsible for mixing that out within concentration. We can select just about any concentration or any gases that we want. We could have up to 8 components. But what we're really talking about today is just specifically for the food gas mixer, and that's 3 components. And normally that concentration is going to be around 65% nitrogen, 35% CO2, and 4,000 parts per million of carbon monoxide. Of course, that can be varied. It can vary quite a bit. Some manufacturers, some producers will only use 30% on CO2, and then they'll just offset that with the balance of nitrogen. The mixer outlet comes out right here and then goes up and out, to the process. It's real important, for a new install that the customer installs these 2 lines that we call a block and a bleed valve. To dial the mixer in, it's important that you would shut this ball valve off here and then vent the gas off to outside to a safe location. If the mix goes out for any reason after the system is up and running, again, you have the same method. You close the block valve and you open the bleed valve here. Hang on. You open the bleed valve here. We also show a line coming from the relief valve that just goes and ties into the vent and goes up and out. It's on the drawing, from an installation standpoint. To be honest, we don't ever expect the relief valve inside of this system to lift. It'd be very rare that we'd ever have pressure of 200 psi on the downstream side. That's what the relief valve inside of the tank, kind of where I'm circling right now, that's what it's set for. The relief valve is to protect that tank, and again, there's just a lot of factors in place that will prevent that from ever getting to that pressure, but we show it nonetheless, and that's fine. One other item on here which is important is that we have a vent line, a very small vent line from the analyzer that's going out. This is shown as a small line. It's typically a 1/4-inch line. People will run that in polyethylene. That's acceptable, but typically it's done in stainless just because everything else is being done in stainless. Now I mentioned that's coming from the analyzer, and what I'm circling here right now is the process analyzer. And so it goes, I think most people know that the analyzer in here is a real expensive device, about a $10,000 analyzer just by itself. And we put that in the unit, and it does really just one function. It reports on how this mixer is doing. So if the mixer is off in any way, the analyzer reports on it, and then in certain cases, it'll send a signal to shut it down. And we'll talk about that a little further today. The analyzer is it's real accurate, and not only is it accurate, we also calibrate it. We calibrate it automatically to a known standard. And so that's what we're showing here with the span gas cylinder on the side, is that the purpose of that span gas cylinder is just to feed cal gas to this analyzer whenever that analyzer is being calibrated. Now, again, to restate, that's not something that the maintenance person does or anyone does on site. It's done automatically. It's programmed in here. We'll look at the screen for that in a little bit. But typical is that we calibrate this analyzer once a week. And it's a real strong aspect of this mixer in terms of a design aspect. You know, we want to be able to mix the gas and mix it very consistently, and we want some way to validate that. And so with these two units operating independently of each other, we're able to do it. So maybe to say that a different way, we don't use the analyzer to adjust our concentration. You know, people have said over the years, oh, you could give a feedback into it, you could change your concentration. It's true, we absolutely could. The programming for that would be fairly easy. We choose not to do that because the mixer itself should be able to give us a very consistent outlet concentration. We really don't need to tweak it or to trim it with the analyzer feedback. Rather, we'd rather have two independent systems, a mixing system and a validation system. And so that's really what we do with that. So, all right, so that's a lot just on this page here. We'll go forward, and we can always refer back to this if there's any questions. This is just a good photo of the inlet gases coming in. You can see from left to right, you've got nitrogen coming in here, carbon dioxide, and then carbon monoxide. This is a picture that was taken in our shop, and we were just using a flex hose here. Flex hose is on this. Typically, these are hard piped once it gets to a plant. You might see off the side here, we're tapping nitrogen off. That nitrogen is used inside the unit for actuation of some of the valves, and it's also used for the zero gas on the calibration portion of the analyzer.